Here's a y equals, here's a y equals, and here's a y equals. So let's take a look at all those. You should know what that looks like. Okay, that's done. Y equals half. Oops, can't draw a very straight line here. Y equals 1 is slightly above that. And then x equals 0 is this line right here. Well, what I recommend you do is zoom that in. Zoom that up in your graphing calculator. Is this. Alright, so what you have there, if you look closely, is you have what looks like a rectangle or a square, we're not sure yet, and then we have this little curvature part. So what we're going to do is we're going to take each one of these one by one. Well, technically, we don't really have to take the integral to figure out this area, because this area, look at that, half up to 1, that distance is a half. Okay, this distance from here to here, well, we might have to figure out some points of intersection. So how do we figure out these point of intersections without using a graphing calculator? We take the functions used here and we set them equal to each other. So this function was 1 over x, and this function was 1. So x is 1. That means that the point of intersection is 1. This here was the axis, so what's the distance from here to here? This distance is 1. This distance from half up to 1 was a half. So the area is length times width. We get half for this section right here. Now this one, because it is a curvature, I can't really do a triangle because it's technically not a triangle. So I am going to have to take the integral from this point of intersection to this point of intersection, which I'll find out in just a second. And the top higher level curve is the 1 over x minus the bottom curve. Okay, so how do I figure out this point of intersection? I take these curves involved. This curve is 1 over x. This curve is half. Set them equal to each other, so solve for x, and they intersect at the point 2. So let's just kind of recap what we've done. We've had to split this into two sections. I didn't have to really take the integral because I could figure out the area on my own, length times width. This one's a little curve, so I do have to take the integral. So now I have to do this one by hand. So what's the integral of 1 over x? Okay, that's ln x. And what's the integral of negative half? That would be negative half x. And I'm going to plug a 2 and a 1 in. So that will give me ln 2 minus half times 2. Now I'm going to plug a 1 in. ln 1 half times 1. So I have ln 2 minus 1 minus ln 1 plus a half. ln 1 is 0. So I have ln 2. Then I have a negative 1 plus a half. That will give me a negative half. But remember that that was only from this section of it. I got to bring down this section I did all on my own. So now when I add up all my like terms, my final answer is just ln 2. And because it's a non-calculator problem, I can't really figure out the decimal equivalent.